You're welcome. We are still looking at gaseous hydrocarbons and trying to establish examples of how we can calculate the molecular formula of these gaseous hydrocarbons by simple combustion of these hydrocarbons. Now, we have been given the question. It says 20 cubic centimeters of Q of the hydrocarbon Q were exploded with 150 cubic centimeters of oxygen. The residual gas volume after cooling to room temperature occupied a capacity of 110 cubic centimeters. After shaking the residual gas volume with concentrated potassium hydroxide solution, the volume reduced to 30 cubic centimeters, determining the molecular formula of Q. Now, we have terms here that are familiar that we discussed in the previous video. Residual gas volume. We said residual gas volume is volume of carbon dioxide formed plus volume of unreacted oxygen. Then, that is the volume of 110. That means unreacted oxygen plus carbon dioxide formed will total up to 110. Now, after that, we come and pass through concentrated potassium hydroxide solution. Remember, we said this potassium hydroxide solution is a base. In the mixture of the residual gas volume, it only reacts with the carbon dioxide. So after removing the carbon dioxide, what remains is supposed to be oxygen. So we're saying it reduced it to this. That means after taking the carbon dioxide, what remains is this one. So we can start from here and say solution. Volume of excess oxygen is supposed to be the residual gas volume, which is 150 minus 100 . The residual gas volume is 110 minus 30. Then that one gives us 80 cubic centimeters. It gives us, it is 110 minus 30. We get 80 cubic centimeters. So this is the volume of excess oxygen that never reacted. But remember, we said this is the total volume of oxygen. Now we go ahead and say if we pass through potassium hydroxide solution and the volume reduces to 30, this is 30, therefore should be volume of oxygen that unreacted. So that means if this is volume of oxygen that never reacted, this is not excess oxygen, but volume of carbon dioxide formed. Yes, that is volume of carbon dioxide formed. Because we are saying residual gas volume contains carbon dioxide formed and unreacted or excess oxygen. So after passing through potassium hydroxide solution, then you reduce to 30. This 30 is supposed to be volume of unreacted oxygen. So residual gas volume minus unreacted oxygen will remain with volume of carbon dioxide formed. So, but like I was saying, that the 150 is total volume of oxygen used, but part of it reacts and part of it remains unreacted. So since that is the part of the volume remaining unreacted, then we can still subtract it from this one to ensure that we obtain volume of unreacted oxygen. So that we're going to say reacted oxygen is supposed to equal to the total volume of oxygen minus volume of unreacted oxygen. And that one gives us 120 cubic centimeters. So we need those two values so much. Remember, this 20 is volume of the hydrocarbon. Then after achieving that, then we write an equation of combustion of that hydrocarbon. get carbon dioxide gas plus Y over 2 moles of water. So I've said this is 20 cubic centimeters. The oxygen reacting, this is reacted oxygen, we have realized is 120 cubic centimeters, and the volume of carbon dioxide formed, we have calculated it as 20 cubic centimeters. Now, since we are trying to get molecular formula, we can find the ratios of these volumes. The ratios of these volumes will help us get coefficients of the compounds we are looking at. So we can divide it through by the smallest. Please, we are dividing through by the smallest to ensure we get the molecular formula. So this is 20 cubic centimeter divided by 20 cubic centimeter. 120 cubic centimeters divided by 20 cubic centimeters. So why are we dividing by 20 cubic centimeters? Because we want to avoid a fraction which is less than 1. Yes, we want to avoid a fraction which is less than 1. So this is now 80 cubic centimeters divided by 20 cubic centimeters. So we divide it throughout with the cubic centimeters maintained so that the cubic centimeters can all cancel and remain with a value without units. So here we get 1, and these are obtained as ratios. 120 divided by 20. 120 divided by 20. We obtain 6. So ratio of 6. Then 80 divided by that, we definitely get 4. So what does that mean? Look at the coefficients. The hydrocarbon has a coefficient of 1, meaning that 1 is equal to 1. The oxygen reacted has a coefficient of x plus y over 4. And the whole of this is supposed to be in bracket format. So that means the whole of this coefficient of oxygen is equal to 6. Now, the coefficient of carbon dioxide gas is x. It therefore simply corresponds to the value obtained here. So therefore, Lana must go ahead and tell us that therefore x is equal to 4. X is equal to 4. Now, after obtaining x as 4, then we'll go ahead and say the x coefficient of oxygen, y over 4, that coefficient should total up to 6, because the two have been really found to be equal. Now, we know the value of x, can simply substitute it there, which is 4 plus y over 4 equaling to 6. So we get collect like terms, y over 4 equal to 6 minus 4. So that we get y over 4 equal to 2. Multiply through. This is y over 4 times 4 equal to 2 times 4. So therefore we get y equal to 8. Get y equal to 8. And after obtaining the value of y now, we can now write a statement and write the general formula of the hydrocarbon. So therefore, molecular formula of Q is C4H8. That is where our question ends. Like I said, we need to read through the question and try to extract meanings, useful meanings to ourselves. We need to read the question and extract useful meanings to ourselves. When we are reading the question, establish initial volume of the hydrocarbon. Establish the total volume of the oxygen. And because we are saying that this oxygen is too much, volume is too much compared to volume of the hydrocarbon, simply means all the hydrocarbon will react, but the oxygen, part of it will react and part of it will remain unreacted. Now, after the two reacting, the whole hydrocarbon is used up completely. they will form a gaseous mixture of the water vapor and reacted oxygen and carbon dioxide formed. I'm saying that during a combustion or immediately after combustion, we obtain a gaseous mixture. Gaseous mixture contains water vapor, the gaseous mixture contains carbon dioxide formed, the gaseous mixture contains unreacted oxygen. Now, how do we separate the three? We separate the three first of all by cooling to room temperature. When we cool to room temperature, we are saying the residual gas volume after cooling to room temperature was obtained to be this. So when we cool to room temperature, the water vapor cools from vapor to liquid. So therefore, it is no longer part of the gaseous mixture because it's liquid water which we can measure the volume. So we're not so much interested in that, but we cool to room temperature so that we remove or eliminate the water vapor. Then after that, we remain with the residual gas volume containing unreacted oxygen and carbon dioxide formed. So the two can be separated by potassium, by alkalis. Since carbon dioxide formed is acidic, while oxygen gas unreacted is neutral. So when you pass through sodium hydroxide solution or potassium, then what reacts of the residual gas mixture is carbon dioxide gas, and the remaining is supposed to be oxygen. So that's when we come and look at part of oxygen. If we can have the oxygen unreacted, then that means we can also get the one which really reacted. So we can proceed ahead and be able to find the molecular formula of this hydrocarbon.